Starting. All attendees are in listen-only mode.
Hello, everyone. A very good afternoon to all of you. I welcome you all to this webinar. Before we begin the actual webinar, I'd like to give a small brief on what we are as an organization. EDS Technologies is the largest CAD/CAM, CAE, PLM, ERP solution provider in India. With over 2 decades of experience in various industries, we enable companies in the aerospace, automotive, and supply chains, industrial machinery, high tech and electronics, railways, infrastructure, consumer packaged goods, engineering service providers, defense and research verticals to achieve their business goals. We were established in 1995 and we are headquartered in Bangalore. We also have a direct presence in various cities across India like Chennai, Coimbatore, Mumbai, Kolkata, Pune, Hyderabad. EDST has the largest customer base in the Indian market in PLM ERP solutions, and we have successfully partnered with more than 1,500 customers in various industry verticals. We have established the privileged position in the market and partnered with many global key players like Dassault Systems, SAP, Presagis, and provide PLM solutions, PLM trainings, and trained on-site resources. Today, our presenter would be Mr. Nagananda. He's a senior application specialist here at EDS Technologies. He has over 13 years of experience. So, before he takes over, I'd like to request you all to please post your questions if you have any during the webinar. He will be answering all of them at the end. So, 1 hour from now, he will continue the webinar. And also, another small request at the end of this webinar, we have a small survey. If you can fill that up, it will be very helpful for us in serving you better. So, over to Mr. Nagananda now. Thank you.
Thank you, Gayana. Thank you all for joining this webinar. And next 1 hour, we are going to discuss or present on SIMULIA suits from Dassault Systems. So you are all aware, like using Abaqus in solving your day-to-day problems and sophisticated problems. Having said, in this SIMULIA suite, which is a brand which comprises of Abaqus Unified FEA, along with the Isight, Tosca, and FESAFE. So in today's webinar, we'll present on these three capabilities of SIMULIA suite. So it's always better to use virtually the models instead of going for a prototype right first time. In order to do multiple sequential analysis and also to help you, which helps you by using the virtual softwares, which will definitely help you out in exploring, discovering, and understanding and improving the products as well as the models and the products that you're manufacturing. As discussed, apart from Abaqus, we are currently we are working on help you or present you on FESAFE, which is for durability analysis software and also to estimate the life. In this first, it will be like fatigue analysis. Usually, the component whatever we manufacture or present, so always like it will be having a design process and the prototype process, wherein which there is a possibility of in service like launch delay or warranty claims, recalls, and legal liabilities need to be considered, where we put maximum amount, maybe some 12% or 40% of our money in that prototype building and analysis. So there is one example, such examples on aircraft disaster where three lost aircrafts with many lost lives, and Europe lost of the lead in the jet airlines industry to the USA for the next 50 years, and also a Jaguar Land Rover exhaust manifold prototype, where in which they has to invest more in order to get you the best results by like creating the DOE, and where the key parameters were varied, and the impact of the manifold life could be assessed. Two examples at the beginning. FE-safe presentation. Here, usually the existing Abaqus users will have to be there, as well as they will import the CAD model from the designer, and the analysis for, like, usually we call it as a unit analysis, unit load analysis will be performed using the FEA tool, and then the results ODB files will be presented. For FE-safe, ODB or the output database files will be the input, as well as you will be having duty cycles, that is loadings, as well as material properties, which will like FE-safe has a library of more than 500 material database is being used. With this loading and material property based on the unit load analysis that we have done in the FE tool, so we could able to present the results. So these results will be like considered, like, which will help you to find out the maximum stress region, and also the maximum where the initiation of the crack or the failure location, the element and the node. So FE-safe is supported by like inputs and outputs through this Abaqus ANSYS ideas, master and program, and general comma separated values, as well as output supported by hypermesh, pattern, FEM view, and CADFix, and FE map. Based on the Land Rover Jaguar example, so it was like consuming more time to analyze, and project time scale and was more, and also impossible for account for all conditions, and it was expensive. So later, by using FE-safe, Land Rover could able to like single engine test was about more than 30,000 pounds, and the cost benefits of reducing the 5 engines to 1 engine was like it was a great huge amount of saving, as well as less fuel being used. In traditional method, usually industries will be having a FE tool, but having said, when it moves to FE analysis to predict the durability do the durability analysis, or to predict the life, industries will not be having a sophisticated tool wherein which like they will be having spreadsheet of Simcodes, and wherein they will pick the locations, nodes, and the locations, and there is a possibility of missing certain critical points or the nodes from the component where it is prone to the failure. So it all like will be like unreliable and easy to miss the failure locations, and cannot cope with the complex loading and structural structures, as well as very few real fatigue scenarios or simple uniaxial cases. Here you have an example from Dana, which says about two images. One is the maximum principal stress region, and also shortest life. Industries predicts like sometimes that the maximum stress region will be the shortest life, but it is not so. You can see that two different places where the maximum stress and shortest life are predicted. There is a scenario from Hyundai. You can find a case study where on your left hand side there is a set of loading conditions, and on the above you have a experimental setup and the prototype, and below there is an image which says about the FE-safe analysis being done using Abaqus Abaqus. So you can predict because of this uniformity in the low cycle fatigue loading, the crack has initiated at a notch, and the same thing has been replicated in both the design as well as in the experiment. When it moves to the high cycle fatigue loading, there is a consider a uniform loading, high cycle fatigue loading, then the crack or the failure of that component is located at the same position in both the experimental and design models. But having said, in general, we can't get any uniform loading, whether it is a low cycle fatigue or high cycle fatigue. In that scenario, when there is a combination of both the high cycle and low cycle fatigues, you can see the image which says about the crack initiation, that is the failure of the component, is at the location on a shaft which is away from the earlier location. As well, you can look in the images, both images correlate, the result correlate each other. So this type of loadings that we are going to see in the regular scenario. Also, it can be like used to helps us in manufacturing effects, also can be taken into consideration. So with FECF, like we need intelligent software, fatigue software, like in order to optimize the design for minimum weight or cost, to save time and money with the right first time prototype testing, and evaluate different material options, to study the influence of load uncertainty of fatigue life, and also to examine the effect of assembly and manufacturing processes, and design and validation, validate fatigue test programming, and reduce product recalls and warranty cost, and also to predict accurate fatigue life quickly and more reliably. So how we can proceed in order to identify? Now, if we save, like you can trust if we save because of some of the information which says about the technology-driven or highly qualified and specialist support team, and 60% plus are like on PhD in technical team, and also or more than 100 man years of industrial experience. This fatigue tool, what we are discussing, is a leading fatigue tool in terms of stress fatigue or strain fatigue, and also like it has a leading industrialist have been joint venture in developing this product. Especially this fatigue tool, which works on metal theory, higher of the add-ons. It says about like fatigue of weld joints with in joint venture with the university. So it has been brought out, and that is variety. Similarly, for thermomechanical fatigue, we have FE-safe MF, which is in combination with Federal Mogul, and creep fatigue. We have FE-safe Turbo Life from AMEC, and fatigue of elastomer, that is for rubber, FE-safe rubber, with as well as FE-safe tool load with technologies. How is like more reliable, comprehensive, like advanced features, full technology with unique meaning, and specialist arrow modules, and 3 years development plan to future modules. Standard version of FECF, which includes multi-axial strain life, multi-axial stress life, infinite life, that is DAN1, fatigue of cast irons, property mapping, fatigue of welded joints on base pack, which is using the BS 5400 and 7608, vibrational fatigue, test program validation, and warranty curves, vector plots, signal processing and parallel processing, component for ANSYS workbench, and a component for SIMULIA Isight, and so on. Which is more comprehensive, and it's new developments like in terms of parallel and distribution processing, customer module frameworks, FlexNet licensing, native 64-bit code on all platform, and so on. It has a material base which is like more than 350 plus, or now it is nearing 500 plus material properties are being incorporated in terms of SI units or US, European, and Japanese and Chinese standards. And also users can add their own material and material parameters, which also includes material properties, chemical composition, fatigue properties, and also includes creep fatigue data for fatigue FE-safe turbo life, and also includes elastomer material data for FE-safe rubber, which is unique. And when it comes to the vibration fatigue, a new statistical method for frequency-based vibration fatigue, like superimpose multiple multi-directional PSDs and uses cross-spectral if available, and supports a linear scaling of PSDs and multi-block loading, and so on. It has a facility to add the FEJ can be added into Isight, about which we are going to discuss in the coming slides. As well, a dedicated FECF component based is available in the Isight parameter, and also FECF can be operated or integrated with respect to ANSYS workbench environment. A full integration with parametric and optimization capabilities, as well as FECF systems can be coupled with any multiple components that produce the RST file, and so on. So it's more accurate in terms. That's what we can discuss using the critical distance method, and it is from multiple directions as well. We have some important information related to the accuracy device in accurate results or unreliable results. So the methods based on assumptions and approximations will produce a unreliable results. You never know like when they will be wrong. Accurate results are you in terms of finding correct fatigue hotspots, as well as optimize your design for fatigue and increased confidence that your component will pass the test as right first time, in order to gain from good correlation with the test results. Here are some of the examples to prove, which proves that this particular FECF tool is so accurate in terms of result wise. There is a component which is used in the helicopter, and the testing of this which says that it will like a rotor hub component will take long last for 985 hours, and in FE-safe results will say about 934 hours, where they have used ANSYS as their FEA package. Again, speeding up, it's more speed, like it is an example, Eaton Automotive component, where it has been analyzed on a 2 Intel Xeon CPUs, and the result wise you can see that analysis which has like long last the 19 hours analysis time, as well as there is a Wind Turbine Manufacturer from where we have this model which says about the FE-safe analysis could able to be completed within 2.6 hours. As it is fast, it is accurate. Also, the results are accurate and like with respect to what their results are fast. So there is a no trade-off between speed and accuracy. A unique nodal elimination method in FE-safe ensures that you get your results quickly and correctly, regardless of the complexity of the analysis. And parallel processing is automatic, like distributed processes is available, and speed examples shows are shown are using like out of box type, as well as this is not the case of fatigue software. And like it is easy to use, which is FE-safe is developed by fatigue experts, and the learning curve is very small. It is a GUI based feature based solver, as well as pre-processor and post-processor, which you can like access to this and learn the analysis very quickly using this this particular software. Also, like many default settings are and intuitive interface, you have automatic selection of the most accurate algorithm based on the selected material. A standard analysis can be saved, batch analysis easily be set up and automatically detects complex scenarios such as contact fatigue and changes the fatigue algorithms without user intervention. So we have, like, we can say that it is very fast, very solid, and very easy to use. Here are some of the case studies by Ford company as well as Schaeffler and Eaton Automotive. They have used this particular problem, and they have used FESIF to solve these problems, and the results are in front of you, like how it is correlating in terms of prototype results as well as virtually obtained a result from FESIF. Similarly, some of the references from the industry leaders who are using FESIF and for their to solve their problems, some day-to-day problems as well as sophisticated problems. It has the associative interface in terms of like Altair, ANSYS, PTC, FEE, design, MSC softwares, etc. Some of the existing users globally, which will, like, they are using this particular tool. That's about FESIF, and you can definitely let us go and understand about the next software within the brand SIMULIA, that is Tosca Structure, which helps you to optimum utilization of the material and thus increase the profitability, and also that does you can save the time before, like, you are using this directly to the taking this directly to the shop floor. It's always very important to understand like where exactly the man or machine method, material, time, and money can be saved in order to increase the profit and like go ahead in this competitive world. There is always a remarkable pressure on the customers, on the vendors, where they have to develop models, or they develop the models or manufacture it at the right time with the right material with the right cost, so that it is very difficult for them to sign the PPAP APQP with their customers or with their vendors in order to, like, because there is a lot of fluctuation in the raw material price in this competitive world. So before going to the shop floor or before going to the manufacturing, you can start using these softwares, which will help you out to save the time and material, and thus increase the profit, so that sustainability will be there for a long period, is what we can, like, suggest by using these particular software. The first product that what we discuss is Tosca Structure. I mean, the second product what we're discussing is the Tosca Structure. This Tosca Structure is a optimization tool which is used to optimize the material, and this is a non-parametric optimization tool. Here you have four modules inside this Tosca Structure, which includes the Tosca Structure.topology, Tosca Structure.sizing, Tosca Structure shape, and Tosca Structure.bead. The Tosca structure is to find the design with maximum stiffness in order to increase the stiffness and reduce the material or weight. The Tosca structure sizing will help us to reduce the mass through optimized sheet thickness, and the Tosca structure shape will reduce the local stresses and increases the durability. The Tosca Structure bead, which is a product which helps us to increase the stiffness or eigenfrequency of a sheet metal structure. So this particular tool will definitely help the users and the organizations in innovative designs to accelerate the product development to realistic optimization results considering the non-linearity, and full design freedom for design optimization, and seamless integration with FEM and CFD solvers. Traditionally, the organizations will be having a FE-safe because or FEA tools, but they usually traditionally they used to start with the design, they used to build the prototype, and they used to test. Later, they started interacting and involving FEM products in them, like designing the product, analyzing them, then build, and then testing that. But now, in order to optimum utilization of the material, the organizations are first looking at the optimization tool to increase, like instead of producing 5 products in whatsoever the given material, they always try to increase maybe by 1 or more, so that it will definitely help them to save money. And also, like in here, it will be the optimization, design, analyze, build, and validate. So let us see why this particular product is more necessary. The basic technology here in the optimization system using SIMULIA Tosca structure is to stable and fast optimization algorithms. So you have an interface to Abaqus, ANSYS, and MEC Nastron. There is a seamless integration into your CA environments. Optimization of almost any kind of FE model with the unrealistic number of load cases, efficient handling of very large modules, and easy setup without time-consuming parameterization for full design flexibility, and also fully automated validation and data preparation for CAD transfer, considerations of multiple finite element analysis, and support of nonlinear analysis. That is all 3 types of nonlinearity: geometric nonlinearity, material nonlinearity, and the boundary condition nonlinearity, which also includes the contact. So you can take the support of nonlinear analysis, as well as this particular product can be used both on Linux as well as Windows machine. Having said about this particular product, let us see one of the example where there is a model which is like initial design space and geometry. This has some of the frozen areas. Apart from the geometrical space, design of space, we have some of the restricted regions, like boundary conditions, where we are adding boundary conditions and loading and constraints. Apart from that, those regions are called as frozen area, and the rest of the free region which is available for geometric change or like design space. And then the optimization model will be like applied to this. The objective function will be defined, the design variables will be defined, and the constraints will be defined as well. We will get the topology optimization model, wherein which the material will be removed from the strongest region and will be added to the weakest region to see that the functionality of that particular component is intact, and which can undergo those operational loads and boundary conditions, so that the results whatever we get is intact with the traditional models, thus by saving some material as well as increasing the stiffness of the component. This one is the rough topology model. As well, we have a smoothing and generation of validation files, as well as the meshed model. And then the validation model, which has been validated using Tosca structure as well as the solver, FEA solver. Again, the shape optimization on the topology optimization model, which we'll discuss, as well as the design optimization further design. So which will reduce, there will be a reduction of weight and enforcing the desirable stiffness and dynamic process, minimize and maximize stresses of several load cases, minimize damage and increase the durability, include manufacturing constraints, and design for displacements, forces, eigenfrequencies, etc. Let's see the environment, CAE environment, with which Tosca structure can be integrated. You have a CAE function, a CAD system with which CAE pre-processing, which can be done with respect to Abaqus CAE, ANSYS, ANSA, FEMAP, and so on. Solver-wise, you can use Abaqus, ANSYS, and MSc Nastran, as well as you can go ahead with viewers like Abaqus viewer for post-processing, ANSYS, FEMAP, Hypermesh, etc. You can use the existing softwares also. You can integrate the existing softwares also along with Tosca structure. This will help you as to look fully automatic integration of the non-parametric optimization with the interactive optimization algorithm, as well as Abaqus CA optimization module. Tosca in ANSA environment is available. SIMULIA Tosca Structure GUI, as well as Tosca extension for ANSYS workbench. When you're using Abaqus CAE, or if you are using Tosca Structure GUI or Abaqus environment or workbench, ANSYS workbench environment, you can interact with or integrate with Tosca structure for optimization purpose. So it will be a CAD initiative where you are taking the CAD model, and then the FE model will be there. An INP file or an input file will be selected here. Optimization processing and checking the model, run the optimization, generating the post-processing information, smoothing the option, and finally getting the results. Here all four GUIs, how it is going to work and how you can integrate with the Tosca structure with your existing tool, existing product, as well as how the report and the smoothing option will be there in Tosca structure, which will enhance your operation to reduce the material and increase the stiffness and so on. The first product is Tosca Structure Topology. So topology optimization calculates an optimized design in a given design space for all specified loads and the boundary conditions. The result is a design proposal for the following details design space, like benefits, which includes the significant shorter development time, which will help you start with a very good design proposal and save material, weight, and fuel, as well as prediction of a final design and high quality. Some of the choices, like you can use a volume, mass, a center of gravity, and moment of inertia. Some of the multi constraints, and as well as objectives that can be used here in this object, as well as automatic validation and data preparation for CAD transfer, and visualization of optimization progress by 3D animation sequence results and sensitivity plots. The second module here in topology optimization, Tosca structure, is Tosca structure sizing, a non-parametric sizing approach, which is feasible for large-scale applications with up to millions of designs variables, which optimize sheet thickness for best static and dynamic behavior, and manufacturing constraints capabilities applicable, as well as clustering of shell elements thickness to combine design variable. You have an example where the initial weight was 329 kgs with 350,000 shell elements with 198 shell sections used as a clustered variable. So optimization task was to minimize the mass and increase the stiffness, bending, torsion, and axial stiffnesses. The shape optimization performs the third module, the shape optimization, which performs an improvement of an existing design or complete the component by a modification of the surfaces. That means it works on the surfaces by changing the position of the nodes, thus by fitting the stresses so that the stresses are reduced and the stiffness increases and the eigenvalue increases. So the objective is to like homogenization of the or or as increase of natural frequencies. So benefit is to fast improvement of existing FE models, reduction of stress concentration, increase of durability, increase of natural frequencies, and no need to create shape basis vectors. So non-parametric shape optimization with minimization of the equivalent stresses of optimization of selected natural frequencies, and optimization using results for a durability analysis and so on, like volumetric constraints can be done, as well as various symmetric constraints like plane symmetric, rotational symmetry can be done using this. The fourth module in Tosca structure is the bead applications. So bead optimization determines an optimum location and orientation of bead in sheet metal structures, which will enhance to use the optimization tool onto a sheet metal component where it is difficult because of the manufacturing constraints that an external stiffener is not able to apply, so that we can create the beads with respect to, like, with regular width and the depth of the bead designs, so thus by optimum utilizing the sheet metal component and increasing the stiffness of the component. So the time saving through the fully automated bead calculation is only 2 to 3 solver iterations, and it can clear bead layouts for complex models, innovative directly producible beads, and design through the consideration of manufacturing restrictions during optimization. Non-parametric bead optimization is definition of objective function terms and constraints using the following response types: and compliance displacements, natural frequencies, symmetry constraints, and penetration checks of neighboring parts. Also mesh independent approach can be looked into. It also has Tosca structure has a report facility as well as a viewer to visualize the results. In the report, we can able to capture and combination of Tosca structure optimization results for easy and reproducible post-processing. The collection of screenshots like fringe plots, animation sequence, and XY plots of animation, his optimization history in platform independent VTFX achieves. And it also can be viewed in terms of high performance 3D viewer for Tosca structure data in VTFX archives, as well as using the Internet Explorer, we can create the HTML data, or Excel, or Word, or PPT can be like a result. Reports can be created and can be visualized. A smoothing option is also available, which will enhance our generating for validation inputs in terms of consideration of features, lines of initial design space, automatic transfer of load cases to the validation files. So it's a rough topology optimization, and then it can be smoothened up in design representations. Then the same thing can be solid mesh with transferred boundary conditions, and validation results can be displayed. As well, this model, topology model, can be transferred to CAD with respect to, like, using the CATIA V5 geometry, using RSO methodologies, or like exporting the CAD capabilities formats like neutral formats in STL or IGS, in order to further create a soft design, and which can be either validated using the FE tool. This particular Tosca structure is much more capable in terms of handling non-linear. That means it doesn't work only on the component level, it works on assembly level also, wherein which we can consider the non-linearities like geometric non-linearity, contact, constitutive material loss like material non-linearity, as well as by using some of the element types in design regions. So this will enhance the usage of non-linear components assemblies in reducing the material, or to work with optimum or working in the direction of optimum design. It has a facility to interface with durability products like FE-safe from fat, FL, phalanx, and FE fatigue, etc. The keynotes of SIMULIA Tosca, which helps us in technology, like leadership in technology of optimization by customer-focused development and joint strategic research projects, which helps in focus on optimization with non-linear analysis, durability, and or manufacturing constraints. Integrations like support of the workflow in the preferred CAE environment, direct CAE of existing CAE models in the optimization, automatic validation, and easy CAD transfer. Strong partnership with the leading CAE software vendors. Also performance-wise, like it can be used on high IT investments, existing IT investments, as well as it is fast, parallel, and reliable with the solver technologies. Let us proceed to the next software, that is Isight, which is a parametric optimization tool which acts as a coordinator tool with respect to your existing tools. Like you will be having different departments with different testing or experimental setups, as well as in-house codes, different FE models, FE finite element analysis tools, and CAD models, and as well as experimental results. You will be falling short, like how you can go ahead and use the existing tools, and there should be one coordinator tool which will enhance you to approach to a design and approach to a best result which correlates with your experimental result. So in order to work upon, we have a solution called Isight, which will enhance you to use and fully utilize the available resources currently what you are facing, without able to integrate that with one particular tool. This particular business needs addressed by Isight. Like it will address businesses use many different in-house and third-party applications to analyze the products performance as well as to cost. The capability between these applications is difficult to maintain. Also, a special applications can only be run by a few individuals. The use of all these applications is not standardized, and it's difficult to repeat, as well as business cannot consider enough design alternatives in the time available for product development. So in these cases, there is no only time to look at a few options, and it is unclear if better options exist or not. Always there will be interactions, or they require some coordination with the existing tool, and in order to do the multiple iterations with the change in parameters like parametric results, so that you achieve the goal in a minimum possible time with minimum cost and minimum investment. So there you will have a design concept to build the computer models and choose the strategy, as well as adjust the input files to run the models, and review the output files, and also the meet the requirement, and as well as final design. So automated process, but engineers which will enhance, engineers defines the simulation process and design the goals, automate input generation, run and output extractions, systematic search of the space, and generate more and better choices. Suitable for frequently used applications, repeated applications, many constraints and many degrees of freedoms, and also to multiple steps and consideration of sim flows. The organizations which do multiple permutations and combinations, trial and error method on the existing product in order to increase the efficiency and increase the production and reduce the cost, this particular product will definitely enhance their requirement. coming to the actual concept of this, what is this Isight? This Isight is a framework software package which is used with the existing simulation codes as well as to the new simulation codes to build and execute the simulation workflow, where you can see that coat hanger structure in front of you on the screen. So this screen has multiple components. I think there is some lag. I'll repeat the same. Isight is a framework software package which is used with the existing simulation codes and to build and execute the simulation workflow. The component you are seeing is the coat hangers like structure, wherein which you can engage the multiple components, whether it is the components like Excel sheets that you have the results from your experimental rigs or test rigs, as well as the calculators in order to calculate and use the constants that what you are using individually in all your different departments, as well as to link that to the whole globally in the industry level, as well as you will be having the techniques like design of experiments to find out the design space with respect to minimum, maximum and the middle values in order to achieve more, and to do the multiple iterations with incrementation, like 1 increment or 2 increment, you can do multiple iterations. Like this, you have multiple components which can be intake here. Using their inputs, you can further optimize the result. Isight provides an environment that allows the capture process to be driven automatically towards desired results, as well as uses design drivers like optimization, design of experiments, Monte Carlo, etc. The benefits like which will Isight allows you to easily set up design studies that can be run locally or your design desktop computer, or more often on remote clusters. This will allow you to look at many design alternatives, like quickly, significantly reducing the design time, as well as you can also improve the quality of design and associated warranty costs by studying the variability in the design, and also like considering the manufacturing tolerance on different material properties. I mean to say exploring different material properties. Isight allows you to find a better design for more quickly than with the traditional approaches, by understanding which design parameters are most important in the design space. That can be done, and like it is a very useful in trade-off design alternatives in real time with colleagues and also like stakeholders. The screen that you are seeing is the Isight screen, where in which you have two options. One is design gateway and runtime gateway. Design gateway will helps you out in modeling the models, where in which you have two options again. One is application component and process component. These components will be a drag and drop facility. Application components includes the applications like your existing CAD, FE tools, or your CFD tools, Excel sheets, or some of the comma separated values, hand scripts, the codes that you have written, or calculators, etc. When it comes to the process components, which includes the techniques like task, loop, approximation, design of experiment, Monte Carlo, Six Sigma, optimization, etc. These components will be a drag and drop option. So in the Isight component, you can drag and drop, and you can use multiple encapsulations in order to run a loop within that smaller sub-files, and you can extract that result onto, that is extrapolate that result onto your main Isight process, as shown in the screen. As discussed, these are all some of the components which can be like CATIA, ProE, UG, NX in terms of CAD models, ANSYS Workbench, Nastran, SolidWorks, Simulation or SolidWorks, Abaqus, Adams or ANSYS in terms of C products, as well as the components like approximations, DOE, Monte Carlo, simulation, optimization, etc. So it will be a like where your simulation process like flow. Abaqus component is an activity component. It provides a seamless integration allowing the Isight to access and modify finite element input parameters, which execute Abaqus standard explicit extract numerical results for the simulation and produce output files for visualization of the results by launching Abaqus viewer from the Isight. So you can have the access to look into this when provided when you are having using Abaqus as one of the component. As well as simulation process flow authoring like automatic data exchange with CAE, automatic data exchange with Abaqus input files, automatic data exchange with Abaqus ODB output database files or DAT files, and configurable with and extendable, and also Abaqus solver execution user controls. There is another component called a Simcode, which is used in order to like integrate the arbitrary simulation code you have, where you have an input file as well as an output result, and you need to map that by and you have to have some iterations doing in order to find what if analysis. If you change some of the parameters in the input file, input parameters, like how it is going to affect your result, that parameters work can be done using the Simcode with some of the arbitrary simulation codes. So general way to wrap any of the simulation code, and also it requires no modification of the simulation code itself. Having said, when you're moving the component with respect to like you need to map different components into your existing analysis in order to find some of the permutations, what if analysis, or you want to find like what some of the trial and error methods. So it is most helpful in like to pass the data from one component to another component. The parameters in one component must be mapped to parameters in another component, which will view and edit the mapping of the mapping table, which will help in automap parameters with the same names and types. Manually map are by dragging some from one parameter to another parameter, which will drag a parameter to a component to have it created in the mapped. There are some of the techniques as we discussed which falls under the process components like task, loop, design of experiment, optimization, Monte Carlo, Six Sigma, and dynamic Taguchi, SDI, etc. Let us let us understand a few of the components, process components, which falls under the technique to understand more. The design usually will be based on the components like DOE, like a structured organized method that is used to define or determine the relationship between the different factors and also like affecting a process and the output of the process. For example, X is your different component, how it is going to affect your Y component. Here you can see some 9 design of experiments, components on which the design of experiment is being done, with which the one feasible component has been taken, and the lowest boundary conditions or the material information as well as the informations have been applied to this to understand its journey to the safer side or infeasible side, feasible or infeasible side. So that you can extract the best component from the design of experimental setup with which you are assigning the minimum and the maximum values in order to map that to the result, and how the results are going to change with respect to change in input, and how whether it will falls in your feasible region or infeasible region, so that the further optimization analysis can be worked on that particular candidate which has passed the required test with falling inside the feasible safe zone. So you have like the performance between the trade-off and understanding the design space, which has the capabilities to determine which input variable have the most influence on your solution output. Like parallel executions can be done, used to build approximation models and estimate of all the optimal design. You can also think of it like the original application of a DOE was optimization with a runtime to close a year. Today, the DOE has like also used to provide a sample of an highly quality approximations and to determine the impact of certain attributes on performance characteristics. Again, approximations, there is another component on which we are going to discuss, like approximation, the mathematical models that approximates the relationship between a set of inputs, that is independent variables, and also the output responses, which mimics the behavior of the simulation models as closely as possible while being computationally cheap or cheap to evaluate. Also known for as surrogate models, modeling behavior modeling, or even black box modeling, and also like process or activities, like how it can be like used with an approximate model that estimates the component outputs. Monte Carlo is another technique that can be used to modify the inputs about a nominal value by applying variances through the distributed distribution curves, like which identify the key random variables affecting the responses and investigate the variable of response caused by random variables, and used in reliable analysis, robust design and tolerance design variables problems. Again, optimization, it works on the DOE candidate on which has passed and also which could be able to map the exact result upon which the variable objective function can be defined, design variables can be defined, and can be defined on in terms of constraints, so that optimum results can be mapped which falls within the feasible zone, upon which we can also do the robust reliable design analysis, as well as we can do the reliability check on those models, surrogate models. A Six Sigma analysis can also be done, which like helps in algorithms tends to push the simulation behavior of the product towards one or more constraints until the constraints are active, wherein which you are doing the feasibility check with the reliability or unreliable, with which the reliable we can do the robust and reliable design feasibility analysis upon which the optimized the best results. You can also like variations in inherent in material characteristics or loading conditions, simulation model accuracy, geometric properties, manufacturing precision, actual product usage, etc. Can these variations can be modeled in the Monte Carlo as well as the Six Sigma components. Having said, once the optimization analysis has been done, Isight will provide you the results, whichever the best, which falls in the feasible zone, and which are all the not good or the worst results, which will be in the red color, which falls in the non-feasible zone, can be like highlighted in best in the green color and least in the red color, so that the user can actually catch this values, and you can incorporate into the model, and you can then do the simulation once again to like show the optimum utilization of the resources and to get the best result. Also, it is like enabling innovations and customer collaboration by allowing engineers to discover alternatives and make design trade-offs. Plots with one-click virtual prototype visualization in Abaqus viewer. So whichever the product that you are using for analysis purpose, pre-processing purpose, the same thing can be used when there is a extraction of the points. If you click on one particular point, which will display you the results with whatever the variations or the changes that you have done in the design. With respect to that, it will show the results. Similarly, 1D, 2D, and 3D plots, graphs, and bar charts can be displayed, which will be of real-time attribute trade-off, as well as statistical and post-processing, as well as real-time history plots can be graphed. As well as you have like results which can be done. As well, we have multiple customers list here, which can be used. You can see that some of your principals or competitors are maybe using this particular tool across the globe, and you can also make utilize of this particular tool. And another thing I want to make a highlight here is the power of portfolio. The product, this particular product is called extended tokens, wherein which you can migrate from your existing Abaqus usage to extended tokens. In Abaqus standalone, you are having a GUI and you can access to only that particular Abaqus GUI, and the solver tokens help you out to solve only Abaqus. But when it comes to extended tokens, you have the facility of interacting or using the GUIs of all the 4 softwares, Abaqus, Isight, FESafe, and Tosca, as well as the same set of solver tokens can be used for solving. Earlier it was different GUI tokens and different solver tokens, and it was more of a more cost-wise, it was more it was not economical that time, but now it is more economical, more simple, as well as scalable. The same set of GUI interface can be used to interact with all the 4 software GUIs, as well as same set of solver tokens can be used to do the solving. Either you are using Abaqus, Isight, FESafe, or Tosca. These set of tokens can help you out. The same set of tokens can help you out to solve, integrate multiple solvers in terms of Abaqus, Isight, FESafe, Tosca, as well as you can scalable in terms of speed up your process onto high-end machines, HPCs, and more core machines. So thus it is more economical, simple, and scalable. This is what an introduction to all 3 softwares for those who are using Abaqus currently. So we request you to send your queries as well as your requests, so that our representatives can visit you and give the presentations and demonstration to the particular tool based on these tools, based on your domain and product, which will enhance to speed up your processes and reduce the money, what you call that cost, as well as increase the profit. Thanks for your time. Thanks for your patience listening. If you are having any queries, please let us know. Thank you, and over to Diana.